Hello, this video is for Stat 110, Module 2, Part 8, and includes a discussion of the margin of error when using a simulated reference distribution. Okay, let's go ahead and get started then. So this part includes a discussion of the margin of error and also the idea of a confidence interval. And we're going to use a simulated reference distribution in obtaining the margin of error and confidence interval. So in contrast to testing, a confidence interval does not require pre-specification of a parameter value. The purpose of a confidence interval is to provide a likely range of values for a parameter. Like a hypothesis test, a confidence interval will require a reference distribution so that we can gain an understanding of what values are likely versus unlikely. A confidence interval, again, is just a likely range of values for the parameter. Margin of error is the acceptable amount of inherent variation in the reference distribution. So let us consider just an illustration here. Here I have the parameter value set to 25%, which means the reference distribution is pushed up the number line 25% of the way. The study outcome here is 12, and we usually identify that up above the reference distribution. This is the setup of a reference distribution when we are doing a statistical hypothesis test. In contrast, when we use the reference distribution to determine the margin of error, it does not require specification of a parameter. And in fact, the reference distribution is set directly under the study outcome. So my study outcome in this example was 12, so I'm going to set the reference distribution directly under 12. Now, the margin of error is the acceptable amount of inherent variation that exists in our reference distribution. The acceptable amount is simply the amount that will capture the likely values in this distribution. We're going to continue to use our 5% outlier rule. The likely values are going to be the middle 95% of the values. So what we end up doing when we do margin of error calculations is we keep the middle 95% of the reference distribution. We trunk off or truncate the lower 2.5% and the upper 2.5% from our distribution. Now the margin of error is simply the distance from the middle of the reference distribution out to the edge after we've done the truncation. The plus margin of error would be to the right of the middle of the distribution, and the minus margin of error would be to the left of that reference distribution. So here in this example that I have mocked up, it looks like the upper cutoff is about 15 and the lower cutoff is about 9, with the middle of the reference distribution being at 12. If I take and express these as percentages instead of counts, which is often what we do with the margin of error, the center of the reference distribution would be 12 divided by 28. That's the maximum number or the sample size here. So 12 divided by 28 is 43%. The lower edge was at 9. 9 divided by 28 is 32%. So the distance when I'm expressing this as a percentage is going to go from 43% down to 32%. That indicates that my margin of error to the left, or the minus margin of error, is simply going to be 43% minus 32%, which yields 11%. Likewise, the positive margin of error is going to be positive 11%. So in this example right here, I would express my margin of error as plus or minus 11%. The confidence interval is from one edge or the lower endpoint of the distribution clear up through the upper endpoint of the distribution. So in this example here, the confidence interval is going to go from 32% up to 54%. And again, this is going to represent a likely range for the parameter value of interest. Okay, let's use a real example. And here I'm using a poll from the Star Tribune, which is a newspaper from the Twin Cities. There is a link provided on our course website, and the Star Tribune has many polls. They often will poll Minnesota registered voters to obtain opinions about different things. So here we can see a recent poll was on voting by mail. So the poll that we're going to look at here has to do with the question of, do you support or oppose stricter gun laws in the United States? Information about the poll is provided above in that paragraph. 625 Minnesota registered voters were asked this question about gun ownership, gun violence, and also gun control. Of those 625 Minnesota registered voters, 56% supported stricter gun laws and 31% oppose stricter gun laws in the United States. We often can express this using a simple bar graph, which would look something like this. And what we are interested in understanding is how much is this 56%, so if we go back up to the poll, how much is this 56% going to change if we were to do this poll again? How much is that 56% going to go up? Or how much is that 56% going to go down? We know that that value is going to vary from sample to sample. The amount that it goes up and down is the margin of error. And that is what is expressed here in graphic A. So when I have a lot of variation from sample to sample, then that 56% is going to be bouncing around quite a bit. So if I had a 10% margin of error, it could go as low as 46%, and the proportion that support stricter gun laws could go as high as 66%. On the other hand, if I do not have as much sample-to-sample variation, then that means that 56% is not going to change as much from sample to sample. So in this graphic here, in graphic B, I have a plus or minus 4%. You can see that the amount that it's going to vary from sample to sample is going to be considerably less here in graphic B than compared to graphic A. We're going to use a reference distribution to obtain the margin of error. So are we going to be closer to situation A, or are we going to be closer to situation B here? Okay, so how do I get the margin of error via simulation? Well, I need two quantities from the poll. I need to know how many people took the poll, so that's going to be my sample size. And for this poll, there were 625 registered voters that took the poll. I also need to know the proportion that supported stricter gun laws. So what value do you want to make the margin of error about or for? And that's going to be that 56%. So to set up the binomial simulation app, what I need to do is use that 56%, use the 625. My statistic now is going to be the proportion. So I'm not doing margin of error on counts, but I'm doing it on the percentage scale. So from the statistic, I'm going to be selecting the proportion. And then I'm going to use many, many repeated iterations for my reference distribution. In particular, I'm going to be using 10,000. So let's go over to the simulation app, specify these quantities. You either support or oppose using the 56% here. The 625 is my sample size, and I'm using proportion as my statistic. I'm going to select 10,000 repeated outcomes. So here's my reference distribution for the situation that we're looking at here. A couple of other important aspects of margin of error and confidence intervals is that we're always going to be using two-tailed or two-sided. So we're going to have a plus margin of error and also a minus margin of error. There actually does exist one-sided margin of error calculations, but we're not going to do those in this course. What we do to compute the margin of error, or what we do to obtain the lower endpoint, is to simply just provide an educated guess here in the box. What that's going to do is provide a lower and upper cutoff for the margin of error, or for the confidence interval. Again, the confidence interval goes from the left edge all the way up through to the upper edge. The margin of error here is simply the distance from the middle to each of those edges. So I'm going to use the term margin of error and confidence interval interchangeably, because once I have one, I can get the other. So when I put a lower endpoint of 0.51 in the box here, you can see that I am truncating about 1% of the distribution. So the area in red here is what is being truncated off the distribution. And that is about 1.2%. Now we want this value to be close to 5%. So my guess here of 0.51 as a lower endpoint is a little bit too conservative. I need to move that up a little bit so that I can truncate about 5% of the distribution. So let's move that from 0.51 up to 0.52 and give that a try. So when placing 0.52 in the box here, in the proportion box, I'm truncating about, again, the red is the area or the bars that are being truncated. I am truncating about 4.7%. And that looks pretty close to that 5%. If I try 0.53, I believe I'm going to shoot up above 5% here, but we can try it. 0.53 in the proportion box. Yeah, it looks like I'm truncating about 13% of the distribution now. So a lower endpoint of 0.63, or excuse me, 0.53, and an upper endpoint of 0.59 looks like it's a little bit too much. That would be too liberal of a cutoff. So I think our best guess is this one here at a lower endpoint of 0.52 and an upper endpoint of 0.60. Now you can work with these distributions if you want and try to get something more exact. So if I'm trying to get this 0.466 as close as I can to 0.05. So maybe I should try like 0.521. So now I'm getting out to 3 decimal places, but I can do that. I can play around with the app and try 0.521 in here. And sure enough, when I do that, I get a cutoff value very close to 5% here. So a reasonable cutoff looks like it's 0.521 for the lower side, and then the corresponding value on the upper side, which is going to be 0.599, I believe. So that gives me a very close truncation of about 5% of the distribution. So that's how I obtain the 95% confidence interval. The 95% confidence interval is going to go from my lower endpoint, 52.1%, up through my upper endpoint, which was 59.9%. So again, the lower endpoint here is just the value that I put in this box, and then the upper endpoint is simply the corresponding value on the upper end of the distribution. So the distance from 0.56 down to 0.521, that distance is 3.9%. So to figure out the upper endpoint, I can simply use 56, 0.56, plus that 3.9%. The other thing I could do is go ahead and just put the 0.599 here in this box. Okay, so you can play around or just do a guess and check on what the upper endpoint should be, just like I did for the lower endpoint. So either way will work in obtaining the upper endpoint of the confidence interval. So once again, the confidence interval is the entire range here, the 52.1 up through the 59.9. And these are the values that are likely to occur in the reference distribution. So a confidence interval goes after the likely values. The margin of error for this example would be plus or minus 3.9%. Okay, let's look at the interpretation then of this interval and also the margin of error. So the proportion of study participants who support stricter gun laws in the United States is the 56%. Okay, so again, if we go back up and look at the poll, this number that they reported out for us was for the 625 people, Minnesota registered voters, that took the poll. If I want to talk about Minnesota registered voters in general, so if I want to expand my scope of inference beyond these 625 people and talk about Minnesota registered voters in general, then that's where I would use the margin of error. That proportion, the proportion of Minnesota registered voters in general, could go as high as 59.9%, or it could go as low as 52.1%. That's what that margin of error is communicating. In practice, we usually express that margin of error as something like 56% plus or minus 3.9%. Or sometimes on bar graphs, you'll see a little symbol like this here, which just represents the amount that that bar could increase. So how high could that bar go, or how low could that bar go? And that, again, is expressing the margin of error. So in practice, the margin of error captures the middle 95% of the reference distribution. Oftentimes, the 95% is not communicated, and the reason that is because the 5% rule is so prevalent in practice. So an author might say that the margin of error for their poll is plus or minus 3.9%. Now, they obtain that margin of error by capturing the middle 95% of the distribution. Not the middle 80% of the distribution, not the middle 90% of the distribution, but the middle 95. If we obtain the middle 80% of the distribution, then the margin of error would be considerably smaller. Or if we wanted to obtain the middle 99% of the distribution, then the margin of error would have to be considerably larger. So they do not communicate. Oftentimes, when we report the margin of error, we do not communicate that we are going after the middle 95%. But again, that's standard practice to use that middle 95%. The easiest way to drive down your margin of error, so let us suppose that we want a poll that has more precision. In other words, we want a smaller margin of error. We want to be more sure about the percentage that we're reporting in the poll. The easiest way to do that is to increase the number of people that you select to participate in your poll. So here in this example, instead of 625, what I've done is just mocked up a reference distribution with a poll that had 2,500 people in it, which is 4 times the original number. Here you can see that the reference distribution is much skinnier now. And the reported margin of error for this is going to be much smaller. So the margin of error when I had 625 people in my poll had to go down to about 52 and up to about 60, about 4% or 3.9%. If I quadruple the sample size, so go from 625 up to 2,500, you can see that my margin of error is reduced substantially. In fact, we can show with the formula, which will be presented in the next part, that you need to quadruple your sample size in order to cut your margin of error in half. And that is what I have shown here. Is if you want to cut your margin of error in half, you're going to need to quadruple your sample size. So how about a second example? This one is again from the Star Tribune. It has to do with supporting universal background checks and military-style rifles. So one of the questions was, do you support or oppose banning military-style rifles with detachable magazines? This poll actually had 800 Minnesota registered voters instead of 625. The proportion from the poll was 58% here. So I want you here to go ahead and obtain the reference distribution for this situation. You're going to use 0.58 as the p-value. You're going to use 800 as your sample size. You're going to specify two-sided, obtain many, many repeated iterations, so you can use 10,000 again if you'd like. And then you just need to provide an initial guess and then keep refining that guess until you can identify at least something close to the middle 95% of the distribution. The reference distribution link is right here. Go ahead and obtain a screenshot and upload that for your notes. And then you should be able to answer the questions that I have down below here. There are 4 questions. The margin of error that you obtain should be around 3.5%. At least that is what the poll indicated. And when I did this, I got something close to 3.5%. We have a couple true-false questions here at the bottom. Okay, that does it then for Module 2, Part 8. Thank you very much.